All right, so we are looking now at chapter 2, section 5, because remember we skipped some of these sections at the beginning. We're looking at how we can prove and apply theorems about segments. So we talked last time about algebraic proofs and how we can use algebraic proofs to solve problems. So this time we're still following that same format, but we're going to be using segments instead. So we still have these properties of equality that we went over with algebraic proofs. Okay, again, these can only be used if there's actually an equal sign somewhere in your problem where you'd be adding something to both sides or subtracting something from both sides. We can't use those properties of equality without equality. So properties of congruence. Now these are a little bit different because we're no longer talking about algebra and numbers. So when we are talking about properties of congruence, we have our reflexive property of congruence, which would be for any segment AB, that segment AB is congruent to segment BA. Okay, if you flip the letters around, they're still the same segment, they're still congruent. Symmetric property of congruence is if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Okay, so here I just flipped my letters around. Here I flipped the segments around. So the last one that we have here is our transitive properties of congruence. So if segment AB is congruent to segment CD, and segment CD is congruent to segment EF, that means that segment AB is congruent to segment EF. So this last one here, because they're both congruent to segment CD, that means that they're congruent to each other. So we talked a little bit about congruence back in week 1, but when it comes to segments, segments are congruent if and only if they have the same measure. So if AB is congruent to CD, then AB, the measure of AB is equal to the measure of CD. And then on the flip side, if I reverse these, if AB is equal to CD, then segment AB is congruent to segment CD. Okay, and then the last definition we have here is the midpoint. So the midpoint is in the middle and it divides the segment into 2 equal and congruent parts. So if M is the midpoint of AB, I'm going to draw a picture down here just to kind of help with what that would look like. So if I have AB and then I have M here in the middle and it's the midpoint, that would mean that those 2 segments there are congruent. So if M is the midpoint of AB, then AM is equal to MB. And that's our definition of a midpoint. Last one that we're going to look at before we get into this too much, because we already talked about this before, is our segment addition postulate. So if A, B, and C are collinear points and B is between A and C, this is where I can say the part plus part equals the whole. So AB plus BC equals AC. Okay, so it's kind of a quick review because most of those are things that we've talked about before. We just put some more definitive notation around them. And these are going to be things, again, definitions, postulates, properties are all things that we can use in our statements when we are writing our proofs. So for this one here, we have the statements, we've got to come up with the reasons. And so we have this diagram up here. We have, looks like maybe some perpendicular line segments, and we're told that x is the midpoint of wy. So wx is congruent to xz, and we have to prove that xy is congruent to xz. So x is the midpoint of wy is my first statement here. And if I go up there, that's given to me. Okay, so now it's telling me that wx equals xy. So wx equals xy. And what is the reason that I know that? Well, if I look at the information I have in number 1, I know that wx is equal to xy because that's the definition of a midpoint. Okay, now I have that segment wx is congruent to segment xz, and that is also given to me. So wx is congruent to xz. Now the next step here says that wx is equal to xz. That is our definition of congruence. So if they're congruent, they're equal, or if they're equal, they're congruent, would be your definition of congruence. So for this last one, I have now xy equals xz. Well, if I look up here, I start with wx equals xz. And then I have that wx equals xy. So I took this wx here and replaced it with an xy because wx and xy are equal. So when you replace something that's equal, that is your substitution. If I know that two things are equal, then I can substitute one of those things for the other. I can interchange them if they are equal. So then I know that xy equals xz, so I can say that segment xy is congruent to segment xz, and that again is your definition of congruence. Okay, so this one helped us out a little bit because we had some of those statements were already done. We just had to come up with the reasons. This one is a little bit longer. So we've got one line segment that's broken into a few different pieces here, and we're told that segment AB is congruent to segment CD, and we have to prove that segment AC is congruent to segment BD. So what we're starting with here, segment AB is congruent to segment CD. That is my given. Okay, so I'm going to go ahead and label this so it helps a little bit. So AB is congruent to CD. So if they are congruent, then they're equal. That is our definition of congruence. Now for step 3, they're saying that AC plus CD is equal to AD. So that's what we started with segments back in chapter 1, and that is our segment addition postulate. Okay, now AB plus BD equals AD. Well, it's the same. I'm still doing AB plus BD equals AD. So again, that's segment addition. They just broke it into different segments, but they're still doing segment addition postulate. If you combine the parts together, they're equal to the whole. Now on step 5 here, we have CD plus BD equals AD. So we went to go from 4 to 5. Everything, if you look, this BD is the same and AD is the same, but this AB turned into a CD because up here we were told that they were equal. So when we swap something out with something that is equal to it, that is substitution. So now for number 6, if we look at what's going on here, we have AC plus CD, which up here we know that that equals AD. And then we have CD plus BD, which is in step 5 here, which is also equal to AD. So if two things are both equal to the same thing, then they're equal to each other. That is our transitive property. Okay, so two things equal to the same thing are equal to each other is your transitive property. Now from here, if we look at how did I go now from 6 to 7, let's see what color right. How do I go from 6 to 7? Well, I got rid of my CDs. Okay, I could subtract both of those out. And what I do to one side, I do to the other, and then they're still equal. That's your subtraction property of equality. And I'm going to shorten property of equality here. And so then this last step, I have that AC equals BD. So segment AC is congruent to segment BD is my definition of congruence. Okay, so these can be a little bit, that got all messed up. These can be a little bit difficult. It's going to take some practice. They're all different, even though they are using the same rules and the same postulates. Even though they might follow some of the same patterns, they still are going to be very different problems. So the best thing that you can do is to just keep practicing with these, and eventually you start to get more comfortable with how all of the rules and all the different postulates apply to different problems. And sometimes with these, you kind of start to go through how you're going to prove it, and then you get stuck. And then you have to kind of go back and try to figure out, well, where did I go wrong? Or what information am I still missing before I can finish proving whatever it is that the question's asking me to prove. So try some of these, see what you get. Make sure you're reaching out to us during office hours if you're having problems, because we can help you in a smaller setting in that way.